usually not nervous when I get up in front of people because I feel like I'm teaching them something. I have a funny feeling you guys are going to teach me a lot of stuff today. So be prepared for the I have no idea how to do that. So today is going to be much more of a discussion about how entity resolution really fundamentally changes the practices of behavioral science observation and getting results out of models through that process. So before we go into that, kind of the most important thing to remember is that models don't do bad things. They do what you tell them to. So people do bad things. And the people that do bad things don't often know how to handle the data. So one of the things that we've spent a lot of time looking at is this whole analysis of whether or not we have a flat world or a round world. We still haven't quite figured that out in the data world at this point. But what you'll see is the fact that not only is it unimaginative and depressing, lives in 2 dimensions. As you want to add more dimensions, I go back to BASIC and Fortran here. We had to dimension more fields in the database. So if we wanted 5 different names for Brent Williams, I'd have to say there are 5 different names. If we came up with a 6th, they'd say, forget about it, we're not going to worry about that one. So even the big mainframes are in place at all the big credit bureaus only can store a certain amount of names on you and figure out who you are. The other thing that happens in these data models is we can't incorporate temporal changes. So if we're looking at a subject, whether that subject is an individual, whether it's a business entity, whether it's an object or an event, and we're trying to find the behavior of that event, both tactically in the near term, as well as strategically where it's going in the long term, understanding the temporal change, not unidimensionally, but also polydimensionally, where you're seeing it across temporal changes over a long period of time. Let me put that into what I call easy English speak. If I'm looking at a person's behavior from a marketing point of view, knowing that they go in and they buy diapers on a certain day, put them in a certain age group, you put them in a certain buying group, and the fact that you leave them in that group is a bad thing. And to be able to identify what are the groups that people are going to evolve to and how they get there is really, really important. And so what we're going to talk a little bit about today is how do you actually do some new math in new types of databases that actually do a better job of faceting the data because it's more accurate, and therefore you're able to actually pull out more that you can use in describing the pool of resources. There are natural, which are these time-based evolutions, and then there are unnatural evolutions. Y2K caused us a lot of trouble. I have been diving in some of the largest people-related data sets where you actually get to see who they are and what they do. And I'll dive in a 45 million, 100 million person data set. The first thing I do is I plot out the birth day numerically through the year. And it should be a nice flat line that drops 75% on February 28th. Believe it or not, there is a little bump in September because you're really cold in the winter. And then there's this really strange bump that we had to figure out what it was, so we asked a female colleague what it was. And what happens is there's about a 50% drop in birth dates to the 25th of December. And many people who were about to have their kids induce early. So that's what a normal curve should look like. You all of a sudden start seeing non-normal curves out of that. It's a very quick indicator that they've had a Y2K interpolation problem and they dropped a bunch of 1-1 2000s in there. Also, if you look at the 1-1 date, it's exponentially higher than any of the other dates in the database. So knowing that there are these unnatural variations, just picked up a data set about a week ago where the field length for city was unnaturally just shrunk down to 12 letters. You know, you need 32 to actually get it right. And so the technique that most of the people used to fill in the mainframe database there was to start typing and lose every vowel. So if I try to do any matching against that data set, you'll never make it because you can't do a sound X, you can't do a trigraph, you can't do a Levenstein 1. It's atrocious. And so, we'll talk a little bit about that today. And then there are some things that occur that kind of drive us a little bit crazy. One of them was we used to be able to get a lot of information out of somebody's social security number, where they were born, as an example. It's actually good that we didn't do that anymore because it allowed you to reverse engineer somebody's age and date of birth. Someday, if anybody wants to have beers, I can explain why they did this, because it actually dates back to 1934 in terms of the source of an error. So you also have problems with dates of birth and how they show up, which drives a lot of models. Where are you in the age spectrum? Which order are the dates? How well are they controlled? So what happens is I have a single individual who might have one or two names, a misspelling and an AKA, and oh, by the way, we don't keep track of which one's a misspelling or which one's it's just this person has been referred to this at some point in their life, and I run out of spaces. And oh, by the way, this is what we see mostly in the work that we're doing right now. Oh, by the way, the one that I see most when data is given to me is the one that I put at the front of the list. So if I'm going to make a decision to drop one or the other, okay, and I'll go in and talk to you a little bit about the self-licking ice cream cone of death that occurs from that in a little bit. Yes?
Are you talking about a specific database, or are these general problems with databases?
These are general problems that occur when you want to do computational behavioral analytics on massive databases that are real. I'm diving into whether it's governmental databases, whether it's our customer databases, anything along those lines. The facts of what's in those drive significant model inaccuracy. And so, trying to show you that if you get the entity resolution right, what happens is the precision of your model goes up dramatically. And it's a lot about what my business is doing today. And we'll talk about specifically some of the examples of where models are actually getting better and being able to facet much better, which is the critical piece. So, you then end up with the problem that somebody usually finds a mate for life, and in such they start having kids and more kids, and then they run away. And so what ends up happening, this was supposed to do a little cool, did it run up? There we go. So he runs away from this. And so what's interesting is all through that time, you had a picture of a household of one, a household of two, a household of three, a household of four, and then a household back at some point in there. And the models and the behavioral models that look at householding, because some of the models that you all will do will be looking at from householding, really have to accommodate who is it within the household who's behaving that way. Great example, marketing. I sit there and you guys know Nielsen, how they count how many people are watching what channel. They have no idea what person's watching that channel. Now, if you can figure out a way to take the people off the radar and actually nail down who it is, then you've won the game. And so we'll go into a little bit about that today. So the other thing, and this is a really big pet peeve of mine, is the traditional databases and the traditional analytic tools, and they're the tools that you guys use. You're probably 10 steps ahead of most of the folks that I work with in business. But the traditional BI tool set is made to make pretty graphs understandable by people who actually don't understand the stuff in the database. Distill it up for them. And so they have these great SQL statements on the backside that pull out the data the right way. They do a little bit of data cleansing, a little bit of data matching, and that's all great. The challenge is that you really need node and edge databases, graph databases. So who all in here has had experience with graph databases? So we got 3 people. I'll give a little bit more information on that. So if you think about the traditional database where you've got rows and columns, columns are usually attributes about somebody, rows are different individuals or different cases. The nodal database actually thinks of that differently. A node may be representative of a person, and the secondary nodes that hang off of that might be their phone number, their email address, or it might be this is electronic device number 1, and electronic device number 1 has this phone number, this email address, and this username between these days. And then I gave that device to my kid, and it had a whole new set of information on it. Okay, so when people are trying to do these marketing analytics right now where you don't actually know who they are, there's no PII on these things, but when you don't see a switch in those devices and you don't know to look across those, these nodal databases are really good at solving the problem. Now, the interesting thing about node and edge databases is if I have a node and it represents an entity or a cluster of attributes about an entity, then this thing that goes between the nodes is called an edge. And that edge means you usually attach a verb to it. So if you think of just straight up English sentence structure, what you get is some sort of noun at the front and a direct object at the end. So has name X, had held device Y, shopped at Z. And so these nodes are equally as valuable as these edges because both of them can be in time domain. And each of those can all be evaluated for their accuracy. And so we'll go into that in a little bit as we go forward. So if you don't know much about nodal databases, hyper powerful, but when you try to think about this traditional world of databases, in order to get access to them, what you actually need to do is build this driver layer in the middle of them that actually breaks them down. So what it does is it says, I'm a BI tool set, I might be R, I might be Python, something along those lines. I can't talk to these databases. So I'm going to extrapolate a driver layer, and guess what that driver layer does? It puts it into tables. And so basically you're just going back here to do that analysis. So to give you examples of where this causes problems, most of the big law enforcement intelligence databases are products by organizations that I won't say their names right now, but those products, they get these things called data lakes, and they just take the bucket and empty it into the lake because they've been told that there's going to be this magical unification of data and solving all their problems. And what they get is a lake of nothing, and none of it connects. I think I have better words to describe that in other places. None of it connects, and so when they try to render in these screens, so let's say I have a database full of all the prisoners in the state of Idaho for the last 20 years. And I want to do some cognitive behavioral analytics on it so I can see, can we do a minority report like activity to say what are the behavior patterns that say you're going to commit a crime. We will never do this, but I'm just putting us in a scenario here. If you try to do that in one of these databases, what happens is you're going to miss so many of the connections to that individual. And so people give up on those databases. So I've been working with large government organizations, massive hospital systems, I mean massive ones. They want to predict how well medicine is going to work on you versus you versus you. It would mean millions, if not billions of dollars in savings. And the challenge comes that when you try to actually go get the data out of the database, you can't make any predictive assumptions. Like if you guys retrieve Medicare data as part of any of your analysis, the anonymized Medicare data, you try to pull that in, it's so unincorporated with itself that you can't make predictive models off of it that are more than 2 or 3 variables deep. So consequently, there's a new domain coming out there. You may want to be aware of it, and I'm happy to answer questions on how to get it. As analytics individuals, how many are familiar with the concept of provenance? Is provenance well spoken of? Wow, this is going to be very important. Okay. So provenance is where did data come from? Well, when I've been spending my last 15, 20 years of my life buying data to do analytics on it, I'm not like you guys who get access to these repositories that you've either held and know what the behavior patterns are in them, or can, because of your educational role, do it. I got to go out and buy these things. When I do that, one of the things that occurs is I'll see some strange behaviors in it. One of them was the Y2K behavior. I made them give me my money back for that one. So it's kind of that issue. You'll also see this challenge that occurs, and I'm going to pick a little bit on the credit industry right now. There's only one thing that the credit industry can do to actually sell their data to somebody who's going to sell you something. They're not allowed to otherwise. They're allowed to sell to banks who are going to market credit to you lists of people who have this kind of a credit score and who live in this area and who have this age grouping. So if a certain bank wanted to target a certain subset of the population with some new marketing campaigns, they're allowed to do that. It's allowable under the Fair Credit Reporting Act. The challenge is there are numerous instances where we talk about this self-licking ice cream cone, where somebody keeps seeing their own data over and over and over. They believe that it's actually more correct. And I'll give you an example that many organizations, not just credit bureaus, what they do is they send you an offer code on a card. And they say, please fill out this card and you will have great success in life, and I'll introduce you to a Nigerian prince who will give you $10 million. So you call up the 1-800 number to sign up for this new credit offering, and the person says to you, hey, thanks for calling. Give me the number of the claim code that's on your card. And they'll pull up the number of the claim code that's on their card, and they'll say, please give me your name and address so I can enter it in the system. An overwhelming number of times, the data's filled in, and if it's kind of close, they really don't pay attention to it. They're paid by how many they get done. So understanding the provenance is actually understanding why the lie gets told over and over again. So in that example, the credit bureau keeps getting told the same thing back that it told the bank as part of that process. Okay? So telling them something new is like making their head explode when you do that. You know, one of the concepts is that people want to falsify your data. So a lot of my customers spend a lot of time to look on social media to get information about their customer base. The first thing they drive to are those little things that you fill out, like, are you married, are you single, are you trying to get single, are you trying to get married, what religion are you, and when's your birthday? Well, there's a whole chunk of the population that lie through all of those. There's a lot of people who lie about their birthday. I'm not going to put my birthday up there. Now, I hate my sister-in-law because she goes on my Facebook page and screams happy birthday on the real one, so it's not like I'm keeping that good of a secret. But that's one of those funny places where you can actually test how accurately the source of the data is reporting it. So think about that and being able to evaluate products of data that you're receiving, either anonymized or not. The last part of it is when you do a bad job at entity resolution, and I'm going to pick on the Centers for Medicaid Services right now. Has anybody interacted with that data before? Okay, so what Medicare and Medicaid Services is trying to do right now is they want to give you the history of people in the area that you're providing services for. So you can make a good judgment of what care needs to be provided for them and how much it's going to cost and what things provide better outcome. So they take the Medicare claims and the Medicare results, all those things, and attach a number to them. It's not your Social Security number, it's not your Medicare number, it's some new magical number. Hashed, you can't go backwards. Supposedly you can't even connect it to a person if you analyze it smart enough. I still think that's possible. But the challenge really becomes that when you trust that they did the entity resolution correctly, and we'll talk about a lot of examples where they don't, not just CMS, but most organizations don't. Now you're taking a person that you have here and you're building a model on this person and you're missing a third of their data. There's these computational desires to get what's called the customer 360. I want to be able to predict what customers are going to buy, when they're going to buy it. Is it raining? Is it not raining? Did they just go to Macy's, Gap? All those other things that are going on in the world, this world right now. You're missing at least 30% of that data on your entire population. And I'll give you a little bit of background on that. Why does this problem impact you? Given what I've heard today so far, I think a lot of this might be new. How many of you all have ever dealt with, purebred entity resolution issues or master data management? Does that fall in here? Okay, you got it? Okay, so entity resolution, this whole idea, I'll give a hospital case infrastructure, that my legal name is Jeffrey Brent Williams. Notice I don't go by Jeffrey. I resent my parents for having named me that for years. My records in DOD, because I was a military member, all say Jeffrey B. Williams. my records military until people started using electronic health records. Sometimes say Brent Williams, sometimes they say Jeffrey Brent Williams, Brett Williams, and sometimes they say Brett Wilson. And so getting those records to all come together and say that has to be Brent, this one carbon-based life form, really, 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 really hard. And every hospital considers this one of their critical issues, being able to not give the wrong medicine to the right person, make sure allergies are lined up. And then they're looking at it from a cost control point of view of what are the behavioral analytics of what subsegments of the population respond to what versus what. And it turns out their base assumptions of data are at best incorrect. And I'll tell you that it's a lot worse than that. So why? So two guys, a guy named Faligi and a guy named Sunter. And you can do a little bit of a lookup on these guys. Invented a probabilistic algorithm, I think back in the 1950s. It is still the prediction algorithm that's in place today. So the healthcare industry uses it, the manufacturing industry uses it. And just so you have a context here, from a manufacturing industry, I manufacture a part in China. And the Chinese company that produces it has a serial number and a part name. I bring that part in and I either put it in another automotive piece, so it's a sub-assembly going into a larger assembly, or I just say, I don't want to hold on to that Chinese part number, I want it to be my new part number. And so what ends up happening is we get these problems called supply chain risk. And you've probably heard about that on the news and things along those lines. It's because we can't actually go backwards and find the origin, the provenance of a device in many times, because you actually can't look at a universal enumerator going backwards. And so getting these things right is really, really critical, and they've been doing it for years. The problem is this little error rate that's driven in here. So to take it back to the subject at hand, to get to the point that your models are actually performing at a very high degree of accuracy, getting the data aligned and those entities resolved actually will yield a 20 to 30% increase in the fidelity of your model just by getting the data aligned. Anybody want to do a research project on that? I know some folks that would pay for that, okay? So to give you an idea, if we think about this as a probability that A is equal to B in a large data set, and A is equal to B, and we just don't know if we can detect it, depending upon the attributes that we got, because they could be attributes from 50 years ago, and now they've gotten married and moved from France to the United States, where 1s and 7s don't look the same, and all kinds of other errors that we see in data. So there's some threshold where every single pairing, you'll get it right as a true positive all the time. And the products that do this, they don't ever want you to know that there's a probability, because they don't know what the probability is. They can just do the best they can, and then they can't do any more. So they tout these, oh, we've done this by hand on 10,000 individuals. It's not doable. It's actually doable. So what happens in that particular case is a bunch of experts inside the organization, like the hospital, sit there and look at the matching algorithms, and they tweak the knobs. There's about 50 different elements that you can have. They have rules lists that DR means doctor. So if somebody spells out doctor and DR is there, we know what it means. Then sometimes that puts, like, if your name is Drew, you become Dr. Oo. So there are little problems like that happen. But the whole point is they're afraid of the liability of matching two words incorrectly. And it's a pretty big problem. So there's this thresholding. You can say, 5, 6, 7, 9's a reliability. I don't have a false positive. And they do a pretty good job of doing this, but the problem is this trash heap below here. Because we don't go from probabilistically a perfect match to probabilistically a perfect no match. It's impossible. It actually was the basis of a lot of my early research when I founded the company called Verata, is actually being able to come up with what does this curve look like and what's the number of people or the number of subjects in here. And mathematically, after doing a little bit of calculus on it, we kind of came up with that it's going to be around 30%. This is Brent calculus, where I actually measured squares and tried to figure out how big the squares were and measured a lot of squares and then up, like real calculus, but the hard way. And so that's where we actually came up with the number based upon what we were seeing. What some institutions do is they go in and they do a manual data review. At this threshold, you shall not pass. If you're below that threshold, you don't match. Do that, you drop this massive amount of people off the face of the earth that really should be matched. And so this throttle here that drives where's this threshold is actually not knobs and twidgets. It's dollars, it's people, it's liability. So how important is it that every one of them is right? I don't care about any of them that are just slightly wrong. How important is it that I've got to get all that are right, even if it's below the threshold, and try to get there to solve it? Most of the organizations that I've worked with in healthcare put 5 to 10 people on this. So it's a $2 million per a small size hospital system. Cost of them to manually review those records. And then, oh, by the way, you know, Jane Schmuckatelli, who got married and became Lisa Smith, ends up here in this ash heap of no matches. This disproportionately hits females. It disproportionately hits people of non-US origin because of name, even date of birth variations and standards. So this is a really bad pool to be going wrong when you're trying to get social services based upon these platforms, make sure somebody's getting continuity of care on these platforms. You're actually disenfranchising people that you should be able to get. Like when you give them your insurance card and they say, that can't be you. So that's a bad problem. Compounding this problem is a very simple math equation that I picked up from my kindergartner. When you take two things that are a certain amount right and a certain amount wrong against each other, you get the product is how right and wrong the next thing is. Think about it as if I want to share information from one hospital that has it 70% correct and one with another one, overlap population where we'd say, hey, we've got these records that we can share with each other so we can create a comprehensive picture on something. Actually, 49% correct. Now, those are rough numbers, but the principle. So you think about that, unless you're going through and rebuilding the matching algorithm, refolding it on top of itself, which nobody I know does, you're operating with a 50% correct. And so we'll talk a little bit later about a case study of states and locals who go through this challenge. If you're born in one state and you die in another state, and they send, first they have to find you, match your identity to the person who lives in the state if you just died. So that's one match, and if they can't find you, they just throw it out. If they can find you, now they got to go back to the original state and tell them you died, because the birth record has to be told you're dead. And there's a very low hit rate on that. They really don't actually throw it away. They try to find the match, but it's not that accurate. So let me give you some examples of why this matters. I picked these examples to kind of give some problems. I'm glad somebody laughed at one of them. These are things that with a traditional probabilistic-based matching algorithm, these two are the same people on either side of this wall. And these are not made-up events. I've made up the names to protect the innocent here, but they are not made-up events. So this is Sally Smith, another medical record 5 years later. She's Sarah Jones. Okay? If I have a flat database, go back to columns and rows, I have no information that said that this Sally Smith, who was 22 at the time, it's a younger nickname for somebody named Sarah, got married to John Smith and cohabitates with him at this address. And any records associated with Sally Smith have kind of died off. The identity attribute cluster that was Sally Smith has died off, and all of a sudden the Sarah Jones became more prominent. You cannot do that at all in a traditional column and row database. These are the things that tell us I've got a linkage. The fact that I got married to Jane Smith and I decided to go, my name's going to be Brent William Smith. You need to have that information. Nodal databases can possess, hold on, track, find that, determine the cohabitative relationship. Is it husband-wife? Is it brother-sister? Is it parent-children? Just based upon a whole bunch of intuitions. So when you look at, I shared with you that I don't like artificial intelligence. I like artificial intuition. So how do you teach a machine that those two are brothers and sisters instead of boyfriend and girlfriend? Hispanic last name variations. We do a lot of work in California, and in that particular case, there's a large Hispanic population. This particular individual, the name was recorded as Pat in the system. You'll see that, is everybody familiar with what 11.1 is and 11.2? Is that new for folks? Okay, so 11.1 is a one number variation from truth. I'm oversimplifying this a little bit. And 11.2 is a two number variation from truth. And so if I wanted to find everybody who had that security number, but I wanted to accept a lev1 or a lev2 of it, technically the way you have to write that is I've got to flip each character each and every time n number of times to create that. And a lev2 is n squared of that. That's all done algorithmically nowadays, so we don't have to worry about it that much. And also we added inversion here. This is actually one of our clients' individuals. Another very interesting one. This one I was caught on because I've got Dan Brown as a male, Dan Brown as a female, and what they have is a security number that could be a double type, which is what's called an adjacent miskey, where I push the button on there. This is a lev1 of that. So all I really have between are two lev1s. But what I didn't account for is it's actually Dana Brown, and they were twins. So their SSNs were sequential. It's a lev1 on the name, and it was hidden behind two lev1 errors behind it. I made up this one to represent Asian name flipping that happens quite often. We see it everywhere, and I don't know that that would be a surprise to you all, but it's actually go to analyze this. Unless you know that Asian name flipping is occurring, this match will exist. Because first name, middle name, and last name will not align. Sorry, that's my insulin pump there. Lastly, here you've got John Smith and Phyllis Smith. Now, the organization doing when I actually had to find these two people, again, this isn't the real name case. I knew that the errors of somebody putting in man is so high it's actually, not usable, completely not usable. So I never coded algorithms. Hey, if somebody's male and somebody else is male, that makes their match better. But what you do is this logic of people overlapping with each other and people disappearing and reappearing in some place. And I called these two a positive just because of some math. I didn't actually look at them. Hundreds of millions of identities at this time. We called these a positive, and the client organization took the first 750,000 of them and said, you got 21 of them wrong. They came up with that in about 20 minutes, okay? And it took us weeks to get this done. I'm like, how did you false positives in 20 minutes? Turns out the only thing they knew how to do at that particular time to analyze that fast was on M's and F's. And anytime when we didn't have a match of an M and an F, they said it's a false positive. Look at this, they're completely different addresses. We went to the Facebook sites of every one of those people, and they were all transgender. One of them was actually transgender decide not to go through with the process. So they've got a separate name living out there, but their pattern started saying that the two people overlapped. None of these would have been found in traditional entity resolution solutions. Something else you need to know about here is this concept of data quality. So I keep going back to the understanding of the context of the information. So you have a really high fidelity of what do they mean when they give me that number next to your address. So on the top of a credit report, you get one. And if you've ever been through a military background, the investigator comes in and the first thing he plops down is your credit report and says, did you live at these addresses? And did you live them is this when you moved in? And you're like, no, I didn't move in on that date. And they're like, uh-oh, this is a flag. You're going to lose your security clearance. And these folks weren't indoctrinated in the whole idea of what is the context of the data that they're getting. The credit report doesn't track when you moved into a house or moved into an address. It tracks the first date that you applied for credit from that location. So what that made us do in our modeling sets is track the concept of no earlier than or no later than. And so if we know contextually that the date that this occurred is an end bound of I moved into this place sometime before this and I moved out sometimes after it, I established those as the dates, so you end up starting to create date ranges of overlap. So we know these two people couldn't have lived together because we know when they were in each of the houses. So the other thing here, we had some problems with criminal information retrieval. There's 20 organizations that aggregate criminal information in this country. Turns out it's really, really hard to go to every single county, every single city in this country and pull criminal records. A lot of them who won't give them to you, and then those who do, you got to go ask for one at a time, and you have to wait 30 minutes before asking. Really silly rules. There are some companies that when they go out there and do that, they actually sit there for 30 minutes. They hire somebody to sit there for 30 minutes and get the next one, and they do it daily, and they keep it up to date, and they keep it fresh. Then you get these big data sellers who have gotten so big that they can't even manage a force of people out there to get these facts from all these different databases. And what they think they've done is they think they've convinced all of the states to create a unified repository of bad guys. Well, the states, it's a voluntary reporting. There's no time specification when the reporting occurs. So if you buy that data, you're way out of date. And so you've always got to check your from that point of view. And then the last thing we want to talk about here as another problem, and then we're going to get into solutioning off of this, is giving privacy efforts into this arena. So the reason we have experience with these, the privacy requirements, it is forced on, pardon me, I got to keep my insulin pump from yelling at me here. This is why I'm not in the service anymore. The reason we focus on this is, in my experience set, we've done some work for some marketing companies. And the marketing companies, I'm making up this customer, just as an example. Best Buy, as soon as they get anything private on you, they don't want to hold on to it because it's a gigantic liability for the corporation. You should see what the cost per individual, per customer for losing information. So consequently, as soon as they get the information, they start hashing it. They hash first name, middle name, last name, email address, phone number, then they hash phone number and email address, and they hash email address with last name and email address with first name, blah, 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 and 85 hashes on you. Then they go out to people who sell cookies and where those cookies have landed. So when watching you and Amazon's watching all those folks, they have a bunch of cookies on your laptop, and there's these magical unifiers. You have your PII, your real name and stuff, and they have the cookie values. And so the people who put cookie values in get stored, and they then want to know if I get to change the subsegment of this cookie holder. So they never get the PII, right? So none of the personal information gets there. intent is to find a way that you can at least characterize the subset of the population without having to use PhD to do that. I cannot tell you how inaccurate it is. We routinely see 18 to 22% in this success range in that example. Things people do, unnatural things people do is they make something all caps, all lowercase. Believe it or not, that extra having a capital versus a lower means a lot in matching accuracy. When you're trying to do it precisely. Trying to hit something, it actually makes it a little bit easier. If you go through all the techniques of how to create different types of hashes, whether you use SHA-256, RSA, any of those other hashes, the best increase in that data that you can hit is 5%. So when you look at that CMS data that you might be doing here, and you see, 3 different identity numbers that CMS doesn't tell you they're the same person, CMS couldn't tell you they're the same person. They're not like intentionally being evil. You're not going to overlap these on top of each other the right way. Okay, so I came here to share this with you because I figured a lot of you wouldn't know about this whole problem of find and correct so that your models can then become more accurate. I'm in the business of making models about human behavior during login. When you log into a website, being back to see if it's a false persona, if it's somebody stealing an identity, those kinds of things. And so banking industry as our first set of customers, because I just started this company, and we're going into a lot of other sectors as we speak right now. So in order to find out, am I a high net worth individual who has a secretary, and I gave my secretary my changing number token, but it's my biometrics, and I know that because I'm tracking Brent Williams, that he's on board his jet flying to Geneva right now, and he signs in and does a login with the key fob, I know he's in the jet. He couldn't do that. So I'm going to ask the key fobber to then put their finger on the fingerprint reader. This is for like multi-billion-dollar transactions, so they're willing to go through a little bit of trouble here. So it's knowing intelligently, based upon the observation that you're seeing right now, what other vector could I go down to then improve my perception that I have either the right or the wrong individual interacting. Okay, so that's a lot about what I'm doing now. So, a little bit, I'll get into a little bit more of the proprietary information when the camera's not on. But what I want to do is give you an overview and then open up the floor to questions. First of all, you've got to go back to the core rule that the data you're using to capture, whether it's signals off of an IoT device, great IoT device to look at here is the cable head inbox. Who's actually looking at the cable TV when they watch this show? Well, if I can find that all the other family members are somewhere else, I know you're there. Okay? So it's being able to do that reverse resolution. So what we did at Verado is we tested a hypothesis after I saw what credit data looks like. We wanted to test a hypothesis of being able to prove a negative. Could you prove that these two people weren't the same person? So if I've got Brent and Ginger and my 2 sons in the house, how would I then be able to prove that my wife Ginger is somewhere else? Because there's 8,722 Williamses in Arlington County. Okay, that's what one of my favorite subjects is a guy named Sam Schmuckatelli. There's only one. There's actually none. So, but you get in that situation, how do you prove a negative? Law enforcement. Bomb goes off. We figure out who picked up the fertilizer, who bought the truck, who put it all together. And if you're a good bad guy, what do? You hide identity. So if we went to Home Depot and you used this credit card to do the transaction, we'd sit there and say, okay, well, these are all the more than 10,000 pounds of fertilizer bought in the last month, and I'm going to look through all of them and see who actually wasn't there. So in other words, if I'm a bad guy, I'd use my grandmother's credit card to go in and buy the fertilizer. If we can find that my grandmother wasn't there, then all of a sudden you pop to the top. From a math background, this is what's called a non-coincidental event. Okay, so that's all what we're about calculating. You cannot calculate non-coincidental events unless you have the fundamental, I'm not saying it has to be perfect, you have the fundamental to remove the background noise. So if you think of it, it's a signal to noise ratio issue. When you facet out 2,000 different observables that you can pick on to try to create a really ability to isolate what event is not normal, you have to know all other events that were going on. Hard thing to swallow. Also scares the living daylights out of people because it sounds a little bit like Big Brother. But if there's a way that you can do it, that it's actually enhancing the security of something and you're not divulging information through that process, it actually becomes a powerful tool for organizations that haven't had the capability to do that. So that most folks think probabilistically. I think every one of us that's in this room took our jobs and stats class somewhere in high school. And it, maybe your last, but this is when most people take their first. You guys may have done it a lot more. I didn't. I think I failed that class somewhere in my life. Be able to ask a different set of questions. It's not what's the probability that this product is going to sell on Tuesdays if Christmas Day is on a Sunday. You can do that in your database. It's what's the likelihood of a person who has this marketing subsegmentation buy this product for their other members of their family based upon their wants and needs at this given time. So it's looking across the linkages to actually get more finite perception of whether or not you're going to be there. The challenge is I walk around and I try to brief corporate executives on this, and I've seen some guys who think they're pretty important, gals who think they're pretty important, and they really just don't even know the question to ask. So this is like outside of the scope. So what we're doing at Euclidean Trust is actually trying to solve that problem by saying, nobody even asked this question, but if I can give them a panel to look at and a question that they sure would love to know, but they wouldn't have even known how to ask that question before, can be answered, then there's higher commercial adoption of that. So I'm looking at practical applications of some of the modeling that you're doing. I watched on swarm models, and I think it's the coolest stuff in the world. I always think of like into an elevator and how they kind of like back into corners and make sure they don't talk to each other or look at each other, or screens, you can actually look at those. I look at that as a really cool example. 99% of people that you show that to in the commercial marketplace wouldn't even understand the behavioral modeling map. So it's better to say, how can I tell you where you want to put your screen? And just leave it at that kind of thing. So the last piece about this is, organizations like mine, as well as all the organizations that I've done before this, we have a problem that other people in the organization may not have the same shared vision. And as organizations grow, what ends up happening is you start bringing on a lot of developers who are working on pieces of the model for you. They're working on data capture techniques for you. And if they don't get reminded of the big flick routinely, they get the JIRA ticket. And I don't know if you all know what that is, but it's a tasking from a code development process. And it's written in, the user shall be able to click this button and get this result, and that result should come from these 4 files. And what does a developer do? Takes the fastest, cleanest, easiest process to go from point A to point B described on that ticket. They don't sit there and say, oh, I'm going to have some flexible fields because later on they might want to add 10 other layers of dimensions of analysis into this. It's like not dimensioning the database. So really keeping your developers in line as you commercialize any solutions in here is really, really important as a piece of that. I make up a few new words in this section. I feel a little bit like George Bush. My first new word is correctiness. It is like truthiness, but truthiness is a component of correctiness. Okay, so weigh that one out for you. And it's a complete proprietary secret. What are the other enesses that are in that? When you look at this, part of what we do to keep that self-licking ice cream cone of death from going on is we actually look at data providers and score them and evaluate them on how well do they present and keep their data up to date, provide accurate updates, whether they give us, periodic updates and a whole refresh of data. You got to keep track of all that stuff, because if you're assuming they're giving it to you one way and you interpolate it the other way, then you've gotten the wrong picture of the data. So we're always looking at fields in the database that says, Nabisco is really, really bad at giving me zip codes, because they obviously don't have a zip code checker on their data entry form. Really valuable thing to know. Just ran into a problem the other day where the customer didn't give zip codes. And that was the one where I had every vowel removed from the city. Okay, one of them was NBRSWCK. And it said New Jersey at the end of it. Well, there's North Brunswick, New Jersey, and there's New Brunswick, New Jersey. And it turns out, if I was geeky enough, I'd actually find an algorithm to go test to see how often that happens in one state. And oh, by the way, New Jersey is 11-1 away from New York when it's a 2-letter abbreviation. So there's 2 other N Brunswick is in New York. So, you really got to watch out for. So you're always looking to go back to those pieces of truth that you know. I know I have a town North Brunswick. I know I have a town New Brunswick. The streets in those towns. So if I get a street address and I don't get a zip code, then I can look at the street address and I know that that number exists on that street in that area. So you're pre-analyzing truth. You then come back and use it to judge how well your data providers are providing that information. Last piece of it is, ever since I've started working with computers, we always thought of this concept of maintenance where we take down one system, put in a new database, take up, customers would start using the new database and the new system, and then we'd bring up the new system on the other side that's down. And so there were revisions. There were revisions to the software, there's revisions to the database, and the newest fangled form of development is what's called continuous integration, continuous development. It's happening. There are people who are really good at it now. The one thing that is not done well on that process, the one thing that just sits behind, is the data continuously live. So how can I answer a question today and then actually change the answer because I learned a new fact? Immigrants coming into the United States. They weren't here first. Now all of a sudden I see them come in. If they're really close to somebody, I might put them on top of something until all of a sudden they're away. Or I might create them as an independent node that I have very little information about. And therefore, I usually won't use the person because it could be just a mess up. So, one of the things that we are going to be is this concept of little spider bots. They're going around looking at this web and figuring out where the web's broken and then testing which way should I fix this. I'll give you a great example. Some subset of the population, less than 10%, but more than 5%, have multiple SSNs in certain people's records who they shouldn't have that information in. Far less than 1% of the population actually has 2 Social Security numbers. So if I see you with Security numbers, then I'm going to go query whether those 2 Social Security numbers sit on somebody else. And if one sits on somebody else, and it's unique for them, and they don't look like me, then I know to deprecate the value of that because somebody else has it with a high degree of certainty. So those are the spider bots that are moving. Simple one. They get a lot more complex when you're looking at familial relationships and how they connect and things along those lines. The goal is to keep humans from having to solve this problem. Other efforts we practice, just so you all know, I'm going to be honest with you, I really get off on making these cool graphics, but it eats into my, and so you get no graphics on the last few pages. You just get high-level thoughts, and we'll ask a lot of questions, okay? Not a made-up word, but a concept that not many people use is the orthogonality of data. So going to the credit bureau, I keep going to LexisNexis to buy X data. I'm getting the same story over and over again, and there might be some wronginess in there. And so in order to find the wronginess, I want to, put a photon ray right through the middle of it and say, is there some collision in here that doesn't work? The greatest amount of orthogonality is the greatest, to me, is the greatest amount of difference of the business cycles and the relationship between individuals or companies that measure individuals or other companies or other facts. So really cheap and easy, fun way to do it. How many people in here have heard of Mechanical Turk? Okay, it's an Amazon service. You basically say, you put up for bid, hey, go count the windows in all the buildings on Main Street in North Brunswick. And somebody will go out and the address, here are the number of windows on those buildings, and you go down the street. And what you're doing then is getting the windows per building count. Now, just to give you a fact of why this is important is we actually know that in neighborhoods that have a higher level of poverty, you get a higher incidence of crime. So if you go count the number of window air conditioners in a city, and where there's a large number of window air conditioners, the crime actually centers where there are less window air conditioners. Window air conditioners are considered a luxury. Okay? And so there are these things that you never even thought of that you can draw great correlations to when you get done with it. So having some Mechanical Turk concept revolving in your solution. The other part about Mechanical Turks is you got to test them. So once in a while I go up to New Brunswick. I actually count the number of windows on all the doors. And so I know what truthiness is. Got that one. And I know what lyiness is too. So I don't pay that person because they gave me bad information. And so that goes to my next new terms, which are attributification. And I still haven't figured out how to spell it yet. If you think of these databases that I was showing you, these node and edge databases, they're really kind of trees with leaves hanging off of them. And the more leaves you can put on the tree that look like an oak tree has an oak leaf, not a maple leaf kind of thing, as you resolve all those oak leaves being on an oak tree and getting more of it, it gets healthier, gets better, those kinds of things. So it really does beautify your picture something. It makes it more accurate across all those ENIS definitions that I'm not going to give out because they're proprietary. What that does is it lets you tune those models. And so the thing that I want you all to walk away from here today is if you're doing these computational behavior analytics, there's a large source of error in some of the data sets you have. Even knowing where those errors exist is difficult because you don't know what suppliers do in their natural behavior sets that actually mess you up. For example, people who sell you data put fake identities in there. So if that fake identity appears somewhere, they know you leaked the data. Okay? It's your privacy violation. So then that person shows up as a new who's not connected to anybody. You think they're in the witness protection program or something like that. So it's very strange. So those are the kinds of things that happen. I hope this has had some value to you, understanding where this system breaks a lot. And I think you would see the precision coming out in your models a lot more if you're trying to predict behavior based upon past assumptions and do that. So I'll open up the floor to questions. And perfect.